Docker, a very popular containerization platform that is used to deploy almost every modern application these days. So in this video, I will be teaching you Docker from scratch along with a hands-on demo where we will be containerizing a Node.js application. So make sure you watch this video till the end. Let's start.
Welcome to Complete Docker course for beginners. In this course, you will learn what is Docker and why is it so popular, understanding the problem that Docker is actually solving. Next, we learn the concept of containerization to understand the difference between containers and virtual machines. Moving on, we go deep in the Docker architecture to understand how Docker actually works, what is Docker client, what is Docker daemon, and lot more. And to make sure that you understand things more properly, we will be doing a hands-on demo where we create and containerize our first application to deploy it as a Docker container. Doing so, we will learn important Docker commands that you will be using every day as a DevOps engineer. And lastly, we will understand how Docker is used in real life deployment, because learning Docker is not enough. You need to understand where is Docker used in real life deployments. So make sure you watch this video till the end. And to make things easy for you, I have notes created for this Docker course. If you want me to share these notes with you, comment down Docker course in the comment section and I will share these notes with you. With that being said, make sure you like this video and subscribe to CloudSham for more such DevOps courses. Now let's start with our Docker course. Okay, now before we look at the definition to learn what is Docker, I want you to understand the process of how an application was deployed before Docker came into existence. So before Docker, the developer used to write application code in their preferred language, which could be Python, JavaScript, Node.js, anything. Along with the code, we also require necessary dependencies and libraries for the application to work. So we could test this application locally. If it works fine, we then create the deployment artifacts, also known as builds, which could be deployed on production server. But for this application to run on production machine, we need to have the same dependencies, same libraries with the same version, or else it will work on your local machine but not on production. And this was very common before Docker was introduced. Whereas after Docker, the developer used to write the application code, then create a Dockerfile which would have instructions of how you want your application to be. From this Dockerfile, we used to create an image, and then this image was deployed as a container on production server. Using this approach, the application would run fine in any environment without any issues. So this is the problem that Docker has solved. Using Docker containers, you can deploy your application in all environments without having any dependencies or library issues. Now that you have general idea of why Docker is used and what problem it's solving, let's look at the definition of what is Docker. And according to the official documentation, Docker is a containerization platform for packaging, deploying and running applications as containers. So what is containerization? If you have worked on virtualization tools like VirtualBox and VMware, containerization is a lightweight form of virtualization that allows you to encapsulate an application and its dependencies into a self-contained unit called as container. So inside this container, you will have the code along with other things like runtime, libraries, environment, configurations. It will also have its own operating system. And this is why it is called as lightweight form of virtualization. So Docker applications run in containers that can be used on any system, any operating system, any environment, a developer's laptop, system on-premise or in cloud, and it will run the same. So here is an example of how containerization works and how containers are created. We have an operating system on which we install Docker or any container runtime, and using that container runtime, we create three different containers. Here is a container which is running a Java application on Red Hat operating system. Second container is running Nginx web server on Ubuntu operating system, and the third container is running PHP with MySQL on Windows operating system. So on a same machine, we have three different containers having three different operating system, and this is what containerization is, which is a lightweight form of virtualization. To understand this more better, let's look at the architecture of how virtual machines are created and how containers are created. To create virtual machines, we require a hypervisor technology like VMware or VirtualBox. Using that, we can create different operating systems like Ubuntu, Red Hat, Kali, whatever you want in your base operating system. So here's an example. You can see in this picture, we have Oracle VirtualBox where we are creating three different operating systems inside it. When we create these operating systems, we need to define how much CPU and RAM should be given to each operating system. So we are dividing hardware requirements to every operating system that we have in this VirtualBox here. Whereas in the case of containers, we don't do that. We have a container engine and we only separate containers on the basis of what applications are we running on it. This is why it is called as lightweight virtualization, because we are not assigning CPU or memory requirements to each of these containers. And due to this, containers are lightweight and more efficient compared to virtual machines. As they are lightweight, containers are very quick to start, whereas virtual machines are slower to start. Containers are separated by processes, whereas virtual machines are full OS isolation. Containers are highly portable, whereas virtual machines has compatibility concerns. Resource overhead is less. Containers will use less CPU and memory compared to virtual machines, and containers have lighter isolation as well. If you want to learn more about difference between containers and VM, AWS has explained how containers are different from virtual machines. Due to all these differences, here are different advantages of containerization over virtualization. Containerization is consistent test environment for development and QA, cross-platform isolation, ability to scale, and a lot more. Now to start using Docker, you need to first install it, and you can do that from the official documentation. So you can install Docker based on your operating system. You have Docker Desktop for Mac, for Windows, for Linux. I'm using Ubuntu Linux, so I can go ahead with installing Docker Desktop on Linux. All I need to do is to choose my platform, then download this step package. This is going to be similar for you if you're using Windows or Mac. You need to install the .exe file or run a command in command prompt. Make sure you go through the system requirements before you install it. Optionally, I can also run this commands here, but I'm installing the .deb package. Once I do that, Docker will be installed in my machine, and I can start working with Docker, running Docker commands to containerize my application. I'm going to pause the video and come back after the installation is done. After you install Docker and Docker Desktop from the official website, you can open up Docker Desktop on your laptop. This is Docker Desktop, a graphical user interface where you can see all your images, containers, and volumes running in your local machine. Optionally, you can also use Docker CLI, which is a command line tool, and that lets you manage Docker containers using commands. To confirm, you can simply run docker -- version command. This will let you Docker is installed and the version is 25.0.4. This is Docker Desktop, graphical user interface. This is Docker CLI, command line interface. Now in this Docker Desktop, you can see the containers. Right now we don't have any containers, but I can create, and we will be able to see it here. Similarly, you can see the images, volumes, dev environments, and Docker Scout. Docker Scout is a feature by Docker that lets you scan your images for any security issues, and I have explained Docker Scout along with other features like Docker Init in my previous video. You can check it out here. Now once we have Docker installed in our machine, we are ready to start with learning Docker hands-on and also to containerize our application. We create and containerize our application, but before we do that, being a good DevOps engineer, you should be understanding what does Docker consist of, how Docker actually works. So let's go deep in understanding the Docker architecture. Docker consists of three important things: client, Docker host, and registry. Inside Docker host, we have a Docker daemon, which is a background process responsible for managing Docker objects like Docker containers, Docker images. And then you have Docker client. A client is a tool that could be graphical user interface or CLI, command line interface, that is used by the users to interact with the Docker daemon through API calls. So you run the commands like docker build, docker pull through the client, which in return will create containers or create images using Docker daemon process. Next, once you have your images created, you can also store it on registry, which is dockerhub, the default registry. Registries let you create repositories, which are of two types: public repository, private repository, same as GitHub, and we use it to store and distribute Docker images. So registries let you version, distribute, and share images across different platforms. And that is explained here in the text. So if you want me to share these notes with you, comment Docker course in the comment section. Moving on, let's do a hands-on project where we containerize a Node.js application and deploy it as Docker container. Also, we will be pushing that Docker image on Dockerhub. So you will learn how to containerize an application, how to push the image from your local machine to Dockerhub. Similarly, you can also do it to other repositories like ECR. For this Docker project, we will be creating a Node.js application, that is a to-do application where we can create list of items and also check them once we do it. We can also delete them if we want to. So we will be containerizing this application. The code for this is present on my GitHub repo, and I will put the link in the description. So go ahead and clone this code to start with containerizing this application. If you want to learn how to containerize a Python application, you can check out this video where I've explained how you can containerize a Python application using Docker commands. So if you want to learn about Python, you can check it here. In this demo, we are containerizing a Node.js application and the code is here. So I'm going to go ahead with cloning this code in my local machine. So let's go to projects folder, and inside this I'm going to run the command git clone, which will get all the code inside my local machine. Once the code is there, I'm going to open that repository, which is learn docker, and let's open this in my VS Code. So here is the code. You can go ahead and go through it. This code is written in JavaScript. This is a Node.js application which is going to create a to-do app, which also uses Postgres database to insert data into. Now to run this application locally, you need to run some commands, and I'm going to show you how to run it locally, then how to containerize it and run it as a Docker container. In this code, we have list of dependencies present inside package.json that we need to install in order to run this application. If we don't have this installed, it will not run. So I'm going to open my terminal. To run a Node.js application, we use the command npm start. But before we start it, it will give an error saying module not found. So we need to install all these dependencies or else it will not work. So to install all the dependencies, I'm going to run the command npm install. And this will go ahead and install all the dependencies, creating a folder named as node modules here, which will make sure that the application runs having all the dependencies installed. So now if I run npm start command, you can see it gave us the log output saying the application is running on port 3000. So let's go to our browser and open port 3000. So I'm going to say localhost and 3000, and this is our to-do application where we can create stuff and also delete it. This is what we want to containerize. So rather than running it locally on our machine like we are doing it now, we want it to run it as a Docker container. So how can we do that? To do that, we need to follow the Docker workflow. What is a Docker workflow? So you want to containerize an application, you need to follow this Docker workflow where you first write the code. So the developer is going to write the code for the application. We already have the code present, so we are skipping this part now. Second is to create a Docker file. So we need to create a Docker file, which is a file that includes set of instructions on how you want your Docker image to be. Once you have the Docker file, you can run the command to create a Docker image. A Docker image is kind of a snapshot or a screenshot of your application, which you can share using Dockerhub, or which you can directly run as a Docker container. So out of this code, we need to first create a Docker file using which we can create Docker image, and then we can share this image or run it as a Docker container. So let's start with creating a Docker file now. So inside my VS Code, I'm going to create a new file and name it as Dockerfile. Make sure to use the same naming convention or naming format, and you can see there's a Docker symbol here, which means this is a Docker file. One more thing to note, if you're trying to run this npm command or try to run this Node application, you need to have Node installed in your machine. I already have Node installed, so if I run node-v command, you can see Node 12.22.9 is installed in my local machine. If you're facing issues, which means Node is not installed, and you can simply install Node by going to the official documentation saying install Node, and you can install Node for your operating system. I have it already installed. If you're trying to run it locally, make sure you have it installed in your machine, and only then you can run this Node.js application. So now let's start with writing our Docker file. Inside Dockerfile, we will have set of instructions on how we want our container to be. So I'm going to quickly create a Docker file for you. If you want me to explain, if you want me to create an in-depth video explaining all the different Docker file instructions, let me know in the comment section, and I will create a video where I go deep down understanding all the different instructions to create a Docker file. So what are different instructions that we can use to create a Docker file? If I go to the official documentation by Docker and search for Docker file instructions, you can see to create a Docker file, you have to use all these different instructions like from, label, environment, entry point, and these are used for different use cases. We use the from instructions to set the base image on which our container is going to be created. Then we use the env instruction to set the environment variable. We use copy instructions to copy files or folders from one place to another. Similarly, we use cmd, argument, add, and all that. As I said, if you want me to create an in-depth video on all these different instructions, let me know in the comment section, and I can create a practical video explaining each of these instructions step by step. With that being said, now let's start with creating a Dockerfile for our application so we can containerize it. So the first thing is going to be setting a base image. So I'm going to say from. So as this is a Node application, I'm going to use the base image as Node. And you can find all the images on Dockerhub. So if you go to Dockerhub, which is a public registry where you can find all the different images, you can search for Node. So I'm going to search for Node here. And you see Node is here, which is the official Docker image. These are the official images maintained by Node itself or the company itself. So I can click on this, and now if I want to use this, I can simply say docker pull node, which will get this image in my local machine. But I'm going to create a Dockerfile, so I want to use an image or the base image from all these different versions here. So I can choose to use Docker 21-Alpine or anything here. Let's try to use something, let's say 21-Alpine here. So I'm going to say from node : 21-Alpine. So I'm saying I want to create my container based on this particular image. So you can see the from instruction is used to set the base image for subsequent instructions. Once we have the base image set, I'm going to set the working directory, which is the folder inside the container where I want to start working from. So you can see work directory is setting the working directory for any subsequent add, copy command that follow in the Dockerfile. So once I set this working directory, all the next instructions will be running inside this particular folder, which I'm going to set as /user/src/app. Next, I'm going to copy my package.json, which has all the dependencies from my local machine inside my container. So I'll say copy package dot. Along with package, I also want to copy the package lock. So I'll say package star, which means every file starting with package should be copied from here into the container. So package star.json from here inside /user/src/app folder. Now once I have this, I'm going to run the command to install all the dependencies, which was npm install command. If you see, we ran the npm install command to install all the dependencies present inside package.json. So I'm going to say run instruction, which is the instruction to run a command. So using run, you can execute any command. So I'm saying run npm install. This will install all the dependencies to make sure our application is ready to run. Once I have that, I'm going to copy everything from here to my container using the same copy command. So copy dot from dot. Dot means everything, all the files and the folders from here inside the /user/src/app folder. Once I do this, I am now ready to run my application. But before I do that, let's expose a port. We ran our application on localhost on the port 3000. So I'm going to expose the same application using 3000 port here. Once I do that, I'm going to execute or run my node application using cmd. So I'll say npm start. So npm start. So this is our Dockerfile, which has different instructions. First, we are setting the base image, which is node 21-Alpine. Then we are setting the working directory, on which folder do we need to start working. Next, we are going to copy our package.json files, and we then run the command to install the dependency. We copy everything from here inside the container, expose port 3000, and then command to start our application. So we have our Dockerfile ready. Now we are going to run the command to create an image out of this Dockerfile. So if you follow the Docker workflow, after we have the code, we now have the Dockerfile. So we are going to run the commands to create a Docker image from this Dockerfile. So to create an image out of the Dockerfile, we are going to use the command which is docker build. If you want to see all the different commands, you can just type docker and you will get the list of commands. Build an image from a Dockerfile. So the build command is used to create an image from a Dockerfile. We have a Dockerfile ready. So I'm going to say docker. So I'm going to say docker build -t stands for tag, which means you can give the name to your image. So I'm going to say my to-do app. So my to-do app, and then I'm going to say use the Docker image present inside this folder, which is here. So I'm saying docker build -t create an image from a Dockerfile present inside this folder having the name my to-do app. Once I run this, Docker will start creating the image layer by layer. So you can see it's now in building stage, and this is the first layer which is the from instruction, then it will go and execute the next layers to create a Docker image. So very soon we will have an image named as my to-do app, which we can share on Dockerhub or also run it as a container. So you can see it is installing the packages here. Okay, Docker build command has executed successfully. Let's run the Docker images command. This command is to show you the list of images you have in your local machine. So when I run Docker images, I will be able to see that I have an image created named as my to-do app, which was created 14 seconds ago. You can also see this in your Docker desktop, which is the graphical user interface. So now I have a to-do app which is created, and the status is unused. It was created less than a minute ago. The size is this. So now I can go ahead and push this to my Dockerhub, or I can also run it as a Docker container. Before I push it to Dockerhub, let's test out if the image is doing exactly what we wanted. So when I run it, I should be able to see the to-do application on my browser. So to run an image as a Docker container, we need to run the command docker run, and we can pass in some arguments like -it to use the interactive shell, -d to run it as a detached mode in the background, and -p to attach ports or map the ports. So I'm going to say run this application as a Docker container running on port 3000 in my local machine, map to the port 3000 on the Docker container. And with this, I'm going to now put the image ID or the image name so that it can run it as a Docker container. So I'm going to say the name of the image, which is my to-do app. So I'll say my to-do app. Once I do this, you can see it is going to run as a container. So now once I press enter, I get this random number, and inside my Docker desktop you will be able to see that a container is running with the name Happy Nightingale. You can also check that inside your terminal by running docker ps command. The docker ps will give you all the existing containers which are running. So this container is running on port 3000, as you can see here, on using TCP. You can also see it here. So if I open up my localhost 3000, I should be able to see a to-do application here, which is running as a Docker container. So this is how you can containerize your application. You need to first create a Docker file. Using the Docker file, you build an image, and using that image, you run a container. So now we have learned the steps on how Docker works. How do you containerize your application? I want you to try this project. The link for the repository is going to be in the description. Make sure you try this out to understand Docker properly. Optionally, if you don't want to create this Docker file, or if you don't know how to create a Docker file, you can use the docker init command, which is the new command by Docker that will create Docker file, compose file, Docker ignore file, all automatically for you once you run the docker init command. If you want to see how it works, make sure to check out the video. In this, I have explained how Docker init can be used to automatically create Docker files for you. And you can also use this documentation by Docker, where we have used the same application and used Docker init to create Docker files, Docker compose file, and run it using Docker compose here. So this was our application. I hope you try it out. The link is going to be in the description for the repository. Make sure to try this out and share it with your friends or connections on LinkedIn. So now, to understand how Docker is used in real life deployments, we first test our application locally. We first create an image and test it locally. If it works fine, then we push public registries like Dockerhub or private registries like ECR as well. So let me show you how you can push this image on Dockerhub. Same way you can also push your Docker images to ECR as well, which is a Elastic Container Registry, which lets you store Docker images on AWS cloud. Now to push this image from your local machine to Dockerhub, you first need to have a Dockerhub account. So you need to go ahead and create a Dockerhub account if you don't have already. I have my Dockerhub account, so I'm going to go and sign into it. So this is my Dockerhub account, and you can see I've already pushed many of my Docker images. These images are for my previous DevOps projects uploaded on YouTube. This is the microservices projects images, and this is the project from the cloud native monitoring application. This is a Netflix DevSecOps project pulled by 700 people. So you can push your images on Dockerhub and people can pull it as well. I'm going to push this image and I want you to pull it and see if you can run that image in your machine by running this particular command, which is docker run -it. So let's go ahead and push this image. To push an image, I'm going to create a repository. Repositories are of two types, public repository and private repositories. I'm going to make this public so that everyone on the internet can push, so that everyone on the internet can pull that image and try to run it locally on their machine. So let's name this as my to-do app, and I'm going to say short description, image for Docker project, and I'm going to click on create. Once I have this created, I can go ahead with pushing my image from my local machine to my Docker hub. Here you can see this is the command to do it. So we need to have the image with the name as Nasi 101, or else Docker will not recognize where to push it. So before we do that, we also need to Docker login or connect our terminal with the Docker hub. So I can say Docker login, and it is asking me for my username and then my password. So I'm going to put my username, which is this. Optionally, you can also connect to your Docker hub using your Docker desktop. You can see it says not connected to the hub, and you can connect to it by clicking on sign in and then putting your email ID. I'm showing. So let's connect to our Docker hub using the Docker desktop. I'm going to click on sign in option, which will open up. Once I do that, it's going to verify credential, and very soon our Docker hub will be connected. You can see now we are connected to our repository. So let me show you the images we have right now. In our machine, we have a Docker image named as my to-do app. I want to push this image from my local machine to my Docker hub repository. To do that, first we are going to change the name of the image from my to-do app to username / my to-do app, or else Docker will consider this as an official image and it will not be able to push. So I'm going to first tag it saying toggle tag my to-do app to username / my to-do app. You can also check that in the you can also check that here. I need to tag it first and then I can push it to my Docker hub here. So let's do that. Once I press enter, it is now changed. The name has been changed. So when I run Docker images, I have a new image with the name this. And to push this, I'm now going to simply say docker push, and this is now going to push from my local machine to my Docker hub repository, which is here, only when my Docker login has succeeded. So we have connected to our Docker hub from here, and you will see very soon the image is going to be pushed from my local machine to my Docker hub. This is something which we do in production. Although all this process is automated using CI/CD pipeline, the creation of Docker image, the creation of container, and the deployment of containers on Kubernetes is all automated using CI/CD pipeline. And if you want to learn how to create that, you can check out my previous videos. This is how we do it in the production, and I hope now you have clear idea of how you can create a container, how you can create image, and so on. So now you can see in my to-do app repository, I have an image which is pushed a minute ago, and now you can go ahead with cloning this or pulling this image and it will work fine for you. So to pull the image, all you need to do is to run the command docker pull and the image name. So docker pull the image name, which is this. So once you run this command, it will pull up an image and you can start running it using docker run command. So we have learned different commands like docker run, docker pull, docker images, docker ps to check existing containers. If I want to stop this container, I'm going to say docker stop and the container ID, which is this. And I can also delete this container if I want to by running docker rm command. When I stop it, you will not be able to see in the docker ps command, but you can see it in the docker ps-a command, which will show you all the stopped containers. To delete this, I'm going to say docker rm and then the container ID, which is this. Once I do that, docker, you will not be able to see the container anymore. Similarly, if you want to delete any images, you can use the docker rmi command. So docker rmi and the image ID will delete the image, and you can see you can also use -f to forcefully delete an image, and that's how you can delete it. All the commands are present inside this notes here. So the commands to pull, build, image, and everything is present here. I also have a LinkedIn post created where All the different commands on Docker is presented very carefully, very nicely. You can check out this post. If you want me to share it, let me know in the comment section. And these are the commands to build an image from a Docker file, to list all image, to pull an image, to remove a local image, and so on. So
this is the end of our Docker complete course. I hope this video was informative and I've taught you everything about Docker along with the hands-on project. If you have any questions, any doubt, do let me know in the comment section and make sure to subscribe to our channel. Thank you and have a good day.